This is a quick video to give people an understanding about the mechanisms mode and also the constraints. So I've made a positioning constraint, shall we say. I've made a quick part here, which as you can see I've got a handle. That cylinder goes inside there, that then fits inside that block, and this then moved up, and that has to go between rotate round and stops when it hits. So why have I shown it this way? Well, basically a lot of people bring in very complicated parts and want to do positioning constraints and then see the mechanisms and see how it works, but quite often they make it too complicated, or they've not done it much before and they're trying to do it on a real part. So the best way to do this is basically to make a simple part, play around with it, get to understand the positioning constraints, how they work, how they interact, and then you can apply that actually on your part. But it doesn't hurt to go around and actually simplify your part a lot so that it helps you understand what's going on. So to do that, you have to go to the Tools section, and we do the positioning constraints. So what we're going to do is we're going to put the positioning constraints on, and we're going to tell it, and we have different types like align, mate, coincident, concentric, etc., etc. What I want to do is I want to do a concentric. So you pick the part, and then you pick where it wants to be concentric to, obviously circular, and it's there. That's fine. And I think also you need to accept that. And I also want to pick, shall we say, that part there, and I want to select it into there. So we're going to accept that. And it's obviously in the wrong orientation. So what we need to do now is just move this down, I think. And the best way to do that would be to mate this part, that surface there, with that part there. So let's just take this around. So I go to constraints, and I'm going to change it to mate, and pick that face there. And it goes clear when you've got a valid geometry, which enables you then to select something else. So in the case of concentric, if you had two shafts together, once you pick one shaft to say concentric, it goes clear. It means you can then select the outer shaft that you're trying to put together without having to then hide things and move things around. So it's a really nice feature to do that. So what I'm going to do is I'm going to put that constraint. I want it to I want it not align, I want it to mate. So we'll pick it on that one there. And it's put that, so I have to give it an offset. Let's go up 5 millimeters. Apply. Let's have a look. Oh no, let's go -5, shall we say? And I'll click on that. Apply. There we go. That's better. Say done. And so if we now look at that, we've now got our part. You see, it's moved that down. But this is obviously I want that through there. So I need to then put another positioning constraint on. This time I'm going to put in use a distance command. I'm going to say I want that from that face there. Say OK. Now it's coming as 72 millimeters. I want it 20 mil on there. So if I double click on that, I can do -20, and it will go all the way through. So now we've got our part pretty much constrained exactly how we want. Let's go to the mechanisms. Let's turn off collision detection. Let's pick that edge, and oh, hang on. Why is this going on like that? Why is that not staying still? Well, it's very obvious, really. If we cancel that, it's very obvious because it's in free space. It doesn't know where it's going to go. You've got to have something which is anchored to the ground. So what we'll do is we'll anchor two parts here. So what we'll do is we'll take this part here, and we'll see in there you've got mate and align, which is a quick way of joining things up, but also fixing parent, which will, if you then look at the scene, you can see it puts a little pin there, so that can't be moved. So if I put the tri-ball on, I try and move that, it will not let me do that. So it's fixed in the scene. Let's turn that off. And let's take this, including that one, and let's put the tri-ball on. Let's put it into a position so that this is actually going to hit that surface there. Yeah, that's fine. So turn the tri-ball off. So if we now go and click on mechanisms mode, we've missed something, I know, but I just wanted to point something out. As you can see, I needed to fix that as well. So let's click on that part and say we want to fix in parent, and then you can see that should be fixed in parent. So if we now go to the mechanisms mode, we can now rotate that round, and you can see it's going through. But if we was to put on the mechanisms mode and use collision detection, we can then go all the way around, and it will stop at that point. And we go all the way around, and it will stop at that point as well as soon as it hits that surface. So that gives me an understanding of how the positioning constraints work and how the mechanisms mode is also working in conjunction with that. But it's a great way of getting an understanding of how your part will move in situations. So if you're doing a cutting machine or a wire machine or something, it's just a good way of actually seeing how that would work together rather than to use your imagination. But I've also, if you can, simplify it as much as you possibly can, so that it gives you the ability to try it and move things about before you go onto such a really heavy, complicated model. Now, also, if you've got sub parts in an assembly, which need to be fixed, so you've got to play around with, the parts in the assembly, or whether it should be an assembly, or you might even think about trying to change the assembly to move things around, just so that you can get an idea of how it works. So, key to this is KISS, keep it simple and stupid. And so that's the old acronym. I apologize for the joke there, but that's how it works. And I hope you found this video useful. Any questions, please come back to me.